Okay, we need a line for each of the factors for x plus 1, for x minus 1, for x minus 2, and for x plus 2, as well as for the overall quotient. Starting to look like a musical staff or something here. Notice the last two are from the denominator, so when they're 0, the rational expression is undefined. Anyway, at negative 2, this one is 0, so we'll start with negative 2. That's where, and then we have negative 1. So this one is 0 at negative 1. Then we have 1 and 2, where each of these binomials has a 0 at one of those values. So x plus 1 is equal to 0 when x equals negative 1, and it's positive if x is larger than negative 1, negative if x is less. X minus 1 is 0 when x equals 1. It's positive if x is bigger than 1, and negative if x is less. X minus 2 equals 0 when x is equal to 2, and it's positive if x is bigger than 2, and negative if x is less. X plus 2 equals 0 when x equals negative 2. And if x is bigger than negative 2, that quantity is positive. And if x is less than negative 2, then x plus 2 is negative. To finish up this sign chart, we can just, like we're taking the product on down. And a negative times a neg times a neg times a neg is a positive. A neg is a positive, and a neg pos is a negative. The whole thing is negative. Well, 0 in the denominator is undefined. Undefined. Now a 0 in the numerator makes the whole thing 0. And a positive neg positive is positive. And a 0 in the numerator makes the whole thing 0. And a positive negative is a negative. And a 0 in the denominator makes the whole thing undefined. And all positives make for a positive here. So now we know we're looking for where is this quotient positive. Bigger than 0 means positive. Where are the pluses? So let's graph the solution set. Negative 2, negative 1, 1, and 2 on the number line. We'll put circles around each of those. And the pluses are to the left of negative 2. To the left of negative 2 here. Also, the positives are between negative 1 and positive 1. That's part of our solution set. And also, greater than 2, it's positive. So everything to the right of 2 . So that's the graph of the solution set. Since negative infinity lives at the end of the line to the left and positive infinity lives at the end of the line to the right, we could write this in interval notation as the open interval from minus infinity up to negative 2, union the interval from negative 1 up to 1, union the interval from 2 up to infinity. In set builder notation, we can write this as the set of all x such that x is less than negative 2, or x is in between negative 1 and 1, or x is bigger than 2. So here we have three ways of expressing the solution set to this rational inequality.